Okay, good afternoon everyone. My name is Miss Karen Gavileño, your general chemistry teacher. So our topic for today is all about a chemical formula. But before that, let us state our objectives for today. Number 1, we need to represent compounds using chemical formulas, structural formula, and models. Number 2, name the similarities and differences between empirical formula and the molecular formula of a compound. Number 3, recognize the formulas of some common chemical substances. Writing chemical formulas is a way of expressing in symbols the elements present in a compound, as well as the number of atoms of each element present in a compound. Chemical formula states that it is a way of expressing in symbols of the element present in a compound. So compound means it is made up of two or more existing parts of the elements. So for examples, we have the molecules of elements and molecules of compound. So as you can see in the difference, in the molecules of elements, it composed of two the same elements. So we have the hydrogen, the oxygen, and chlorine. While in molecules of compounds, it composed of two or more different elements. For example, in H2O, we have 1 mole of oxygen and 2 moles of hydrogen. Next is the hydrogen chloride. It composed of 1 hydrogen and 1 chlorine. So there are different types of chemical formulas used to represent the bonding atoms to form a compound. So these are the structural formulas, molecular formula, and the empirical formula. Structural formula, it indicates how atoms are arranged and bonded chemically. So for the examples, we have the methane, ethane, the water, benzene, and acetic acid. So as you can see, the structural formula, methane gas composed of 1 carbon and 4 hydrogen, while in ethane, it composed of 2 carbons and 6 hydrogen. In water or H2O, we have 1 oxygen and 2 hydrogen. And benzene, it composed of 6 carbon and 6 hydrogen. While in the acetic acid, it composed of 2 carbon, 2 oxygen, and 4 hydrogen. So these are the structural formula of each compound. Next, we have the molecular formula. The molecular formula is also known as the true formula. So it is the formula that shows the number of atoms per element present in a compound. Okay, for example, we have the numbers of the carbon in the compound. So we have the name in its molecular formula. So we have number 1, methane. So methane has 1 carbon and 4 hydrogen. Ethane has 2 carbon and 6 hydrogen. Propane, it has 3 carbon and 8 hydrogen. Butane, C4H10 or 4 carbon and 10 hydrogen. Pentane, 5 carbon and 12 hydrogen. Hexane, 6 carbon and 14 hydrogen. butane, 7 carbon and 16 hydrogen. Octane, we have 8 carbon and 18 hydrogen, while in nonane we have 9 carbons and we have also H 20 hydrogen. Then the last, we have the decane, we have 10 carbon and 22 hydrogen. So those are the different molecular formula of a compound. Then the last is the empirical formula. Okay, so what do you think is the difference between the molecular and the empirical formula? So in empirical formula, we talk about the ratio. Okay, so it shows the simplest form of the atomic ratio in a compound. So what does it mean? Okay, so for empirical formula, I will give you some example. So for example, we have C4H8. So it is cyclobutane. So by getting the simplest form of this compound, let's first write a fraction. Okay, so we have 4 carbons over 8 hydrogen. And then the most special here in empirical formula is to find the simplest or most reduced ratio of the atoms in a compound. Okay, so what do you need here is you would think what could be the largest number that could be divided both of this. So in cyclobutane we have 4 over 4, so it can be divided by itself. Okay, so 4 divided by 4 gets the number of 1 carbon, while 4 divided by 8 is equals to 2 hydrogen. Okay, so this is the simplest ratio of a compound. So to get the empirical of CH2, so the number 1 here is gonna be written because it understood that in CH2 there is only 1 carbon here that put it inside. So we don't need to put 1 here. So it's understood that this is the simplest or the most reduced formula in empirical formula of cyclobutane. So cyclobutane, they have 4 carbons and 8 hydrogen. Next example, we have the cyanuric triazide. Cyanuric triazide has 3 carbons and 12 nitrogen. So of course, let's write it in a fraction. Then we would think what could be the largest number that could be divided both sides. So it should be 3. So 3 divided by 3 is equals to 1 carbon, and 3 divided by 12 is equals to 4. So our simplest or most reduced formula for the empirical formula is CN4. So it is cyanuric triazide. Okay. So this is the most reduced and simplest form of empirical formula. So another example of empirical formula versus the molecular formula. So for tetraphosphorus glycoside, So why it is tetra? Because it has 4 phosphorus and 10 oxygen. So the molecular formula of P4O10 is equals to P2O5. Okay, so it should be divided into 2. So 2 divided by 4 is equals to 2. 2 divided by 10 is equals to 5. So next is the decay. So decay, 10 carbon. So it can be divided into 2. So 2 divided by 10 is equals to 5. And 2 divided by 22 is equals to 11. Then last, it can be divided into 3. So 3 divided by 6 is equals to 3. 3 divided by 18 is equals to 6. And last is 3 divided by 3 is equals to 1. So it should not be written. So it understood that there is only 1 oxygen in the atom. Okay, next is that you need to know that if the ratio of the atoms in the molecular formula can't be simplified anymore, the empirical formula is the same as the molecular formula. So for example, the molecular formula of T3 and 5. So it cannot be simplified anymore. Okay, so in this case, the empirical formula is the same as the molecular formula. So we don't need to reduce it. Then another one, many different compounds can have the same empirical formula. So for example, the molecular formula is also the same as the empirical formula. We have the C2H4, the same as the empirical formula of CH2. Okay, we have C2H4, C3H6, C4H8, C5H10, C6H10 is equals to the empirical formula of CH2. Next, okay, so these are the different examples of empirical formula. The molecular formula and its structural formula. So methane, CH4, so it is a structural formula. Then we have the nitrogen monoxide, 1 nitrogen, 1 oxygen. So its molecular formula is N2O4. Okay, so here is the structural formula. Our formaldehyde, we have the CH2O. Okay, so we have another molecular formula of CH2O, and its structural formula we have the C, 2 moles of oxygen and 1 mole of oxygen. Then last is the benzene. We have CH, carbon and hydrogen. So of course, its molecular formula we have C6H6. So since it can be divided by 6, so its empirical formula is carbon and or C1H1 or CH. So the structural formula of benzene, so we have 6 carbon and 6 hydrogen. Okay, next is the models. So the models is a representation of a compound of either molecular and structural composition. So it is a 3-dimensional view of a compound. So the balloon stick model is a model that depicts a 3-dimensional view of the atoms of a compound and bonds between them. The next is the space filling model. So it is a model depicts of a compound using spheres. that are joined together, approximating the proportionate sizes of the atoms. So here is the example of the ball and stick model. So they uses colors to indicate the number or the parts of each element. So we have the BF3, so it is the boron and fluorine. So we have 1 boron and 3 fluorine. Then we have C2H4, 2 carbons and 4 hydrogen. Then we have C6H6, the benzene, so these are the carbons and these are the hydrogen. The next we have the CH2O. So CH2, this is the carbon. Always remember that the carbon is the central, always the central part of a structural formula. So here's the carbon. We have the 2 hydrogen and 1 oxygen. Okay, so oxygen is color red. Next, we have the carbon dioxide. So the carbon is always in the center. And the 2 moles of oxygen. So we have the fluorine, nitrogen, and oxygen. The next, we have the H2O, the central part, which is the hydrogen and the 2 moles of hydrogen and 1 mole of oxygen. Then here we have the carbon, hydrogen, and nitrogen. Next we have the hydrogen, nitrogen, and carbon. Then another one, we have the magnesium difluoride. So we have 1 magnesium and 2 fluoride. So those are the different examples of a ball and stick model. Next, we have the space filling model. So space filling, so as you can see, it is different from ball and stick. So we have to fill out the space. So for example, we have the molecule or the water molecule. So the central part is the oxygen because it has 1 oxygen and 2 hydrogen. So the center will be the oxygen and 2 moles of hydrogen. Next, the carbon dioxide. So the central part is the carbon and we have the oxygen here. Okay, for side by side. So it is the space filling. So as you can see here, we have another example, the water and the methane. So these are the models of the ball and stick and its space filling model. So you'd already know the difference between the space filling and the ball and stick, as you can see. Okay, so here are some examples of the molecular structural formula, the ball and stick, and the space filling. So we have here the methane, its structural formula, a model, we have a ball and stick, and its space filling. So as you can see here, in the ball and stick, the central one is the carbon, and we have 4 hydrogen here. Well, in space filling, the central part is the carbon and here is the hydrogen. Then for letter B, we have ethane. So in structural formula, 2 carbons and 6 hydrogen. So we have the central part, here is the carbon, and in the outside part, we have the hydrogen. In space filling, of course, the 2 carbon are at the center, while in the outside part is the hydrogen. Then last is the ethane or the ethylene. So have structural formula of 2 carbons and 4 hydrogen. So as you can see in the ball and stick, we have 2 carbons and 4 hydrogen. Then in the space filling, of course, we have 2 carbons here and the outside part is the hydrogen. Okay, so those are the different examples of the chemical formula. We have the structural formula, the molecular formula or the true formula, and the empirical formula, which is simplest form of ratio. Then the models of each compound. So we have the ball and stick and the space filling. So those are the different examples of chemicals formula. Okay, so that's all for today. Thank you for listening. So if there's any question, don't hesitate to ask me. Thank you and goodbye.